I'm Arve Knudsen. I'm a senior software engineer with the Grafana Labs, where I work on Grafana Mimir. But I'm also a maintainer of the OTLP endpoint in Prometheus, together with Jesus.
Hello, everyone. I am Jesus, also a senior software engineer at Grafana Labs, and I've been working with Prometheus a few years now. Lately, I've been spending time with the OTLP endpoint myself. Before we get started, I'd like to ask how many of you, a quick hand raise, how many of you have worked with OpenTelemetry in the last year, like any kind of work, maybe working with the SDK, setting up a collector, receivers, exporters? OK, maybe 10%, 15% of the people? That's good. It's just to keep track of that percentage growing over time. We would like to see what happens next year. All right, so last year, around this time, Gotham and I brought you a talk about how Prometheus wanted to commit into becoming more OTel native and some of the challenges that we were facing. Some of those challenges were properly handling resource attributes. What were resource attributes in the OTel spec, how to handle that in Prometheus, and then UTF-8 support for metric names and attribute names and values. The push versus the pull model, because as you know, Prometheus is pull-based, but OTel is push-based, and how to blend that in. And then the differences between cumulative and delta temporality, which both are valid according to the spec, but Prometheus is just cumulative temporality. So this time, what we're bringing you is a few updates on each of these topics. And I give it to Arve to give you the first one.
Thanks. So the thing with OpenTelemetry is that it has this concept which it calls resource. And the resource basically corresponds to the entity producing the metrics. So it has a set of attributes describing each resource. And those attributes are basically key value pairs, metadata. So, the problem when ingesting OpenTelemetry metrics in Prometheus kind of becomes how do you keep these resource attributes. So one method we can recommend is to copy or to promote these attributes to metric labels, although just a select set of them, because otherwise, if you would copy all of them, they would be too many. And this method basically corresponds to how historically Prometheus has copied promoted metadata about scraping targets as labels. So as I already mentioned, one shouldn't promote too many because you will end up with performance issues if you have too many labels per metric. And also there will be UI clutter, simply due to having so many labels per metric. So we have put together a recommendation where for promoting 17 certain resource attributes, which we found through experience are typically useful to users. But then I'd also like to mention that there's a query time alternative to promoting resource attributes to metric labels, because the resource attributes are already automatically encoded as labels on the metric target info. Since they are already encoded, as it were, as target info labels, what you can do is you can include target info labels in your queries through so-called PromQL joins. So the benefit of this is that you don't have to decide at ingestion time which resource attributes you want to include, and then if you were to change your mind about which resource attributes to promote, you would also cause series churn because you would have the old version of the series and then the new version of the series with the different resource attributes being promoted. So you can avoid this by instead including target info labels at query time. So the challenge with this is that the writing join queries is tricky, and you can also end up with join conflicts in case one or more resource attributes were to change, because then you'll have for about 5 minutes the two versions of target info. They will have the stale version until that is considered too old after 5 minutes, coexisting with the new version. So we have come up with an alternative, which is a new to join queries, which is a new PromQL function called info, which offers a much easier user experience. Because it's just like a function call, and it also has performance benefits versus traditional joins, because when you join the target info, you specify which target info series to fetch, but typically you won't be able to filter down to exactly the ones you need, so you fetch too many, whereas info, it fetches just info series with the correct job and instance labels, because those are the ones which are used to join to see a time series. So info is not yet in the main branch of Prometheus. It's under review for inclusion in Prometheus 3.0. And this is an example query. This is an example join query, how you would traditionally include labels from target info, and those labels would, of course, represent OTel resource attributes. So basically here you have a rate query on a metric, and then you multiply that on the job and instance labels with the target info metric, and you pick just the K8s cluster name label. So this is the equivalent using the info function. And here you see you no longer have this multiplication. Instead, you just have a call to the info function, where the first argument is the rate query, basically. And then there's a second argument, which is in fact optional, where you specify that you want the K8s cluster name label. And you also specify that the K8s cluster name label has to be non-empty. So this screenshot demonstrates an info call with only one argument, where you don't specify any label matchers. And there you see that a lot of labels are added to the query result. All the K8s underscore labels, for example, are from OpenTelemetry resource attributes. And here's an example, a demonstration of calling info with a label matcher, the aforementioned label matcher on K8s cluster name. And then you see that there are much fewer labels. So basically, in addition to the time series original labels, only the K8s cluster name label is added from target info. And then I should like to offer a quick peek into the future, where we foresee that we will start persisting OpenTelemetry resource attributes as native metadata in Prometheus, because we are currently hashing out a design for a proposed metadata store in Prometheus, and it's at this stage. We have 5 proposals which are under discussion in a public design doc, and we would very much welcome feedback from the community. And here I'm going to hand it over to Jesus.
Right. Next up, we have UTF-8. So this is a common error for users that are coming from other monitoring systems or just using OTel SDK. For us, Prometheans, we're so used to using underscores. Like on every metric, we know those are the common practices and have always been. And it's kind of natural, or at least that is for me. But there is a whole new set of users out there. And Prometheus wants to be a good backend for those and welcome them as well. And this is a point of friction because imagine you're writing on your code and you create a metric and you use a dot instead of an underscore because you're not familiar with the Prometheus restrictions on names. And then you go and query that metric and you get this error. So this is what we are trying to fix. The good news is there's a lot of progress on UTF-8, but I don't want to give you any spoilers. Owen Williams will take care of that later on today. What I can do is I can tell you how it's working at the moment. And there's two ways of getting OTel data into Prometheus. You can either use the Prometheus remote write exporter in the collector or write to the OTLP endpoint. And these two things are using the same, what's called the Prometheus normalization translator package, which is basically enforcing current Prometheus restrictions on the incoming data. So basically, if you send dots, you'll get underscores. And it normalizes every data. It normalizes metric names, it normalizes labels. So right now, there isn't much for you to do. However, as the UTF-8 feature matures, what we are thinking about doing is adding a feature flag to the code base, where basically we can maybe opt in to disable this translator thingy. And actually, Arve and I think this is a very simple change to do in the Prometheus code base. So if you'd like to do your first contribution to Prometheus, you can actually ping us, and we will point you in the right direction, because we've already looked into it and should be easy to do. Next up, we have the OTLP endpoint. It's now stable, or it's in the works of becoming so for Prometheus 3.0. This time last year, I think we got it just merged for the presentation, or it was about summertime as well. And yeah, so it's been a year. We've been using it in production, and we think it's stable now. So that's good. We strongly recommend for you to enable out of order if you want to use it. And the reason for this is that the OTel collector encourages batching. So it batches up the metrics you write to it. And as soon as you have multiple replicas, they won't coordinate to send them. And you will run into out of order very naturally the moment you do that. Yeah, and also a few weeks ago, we just learned about a new behavior where counter restarts, that maybe you want to introduce zeros before the first sample that you scrape. And so that will also lead to out of order. So yeah, out of order is in main already. You can enable it, and we strongly recommend for you to do it. Another great improvement here, and this is less user-facing, but more like contributor-facing, is that last year, when we merged the endpoint, Prometheus was still vendoring the Prometheus remote write exporter code in the OTel collector. But because the OTel collector also vendored Prometheus, we kind of have a cyclical dependency. And maintaining that was a nightmare, because basically we had to, whenever there was an update, we had to run some scripts and then some replaces to make everything work. And yeah, it wasn't nice. And so this has taken a lot of community effort. I think Arthur, Arve, Juraj, David Ashpol, Gotham, Anthony Mirabella, many people, both from the Prometheus community and the OTel community, in multiple calls on a bi-weekly basis, we've been discussing about this. We thought about extracting a library with the translation code, but then who would own that library? Who would depend on that library? It was challenging as well. In the end, we decided to diverge, and basically Prometheus now owns its own copy of the code, and that has made things much easier to maintain. Actually, it's true both code bases have diverged, but they're essentially doing the same thing, and it gives us headroom to actually make improvements. And we've been at it. And the translation code in Prometheus is now 40% faster and consumes 60% less memory. So that's good for everyone. Earlier, Arve was talking about promoting attributes on ingestion in case you want them in your metrics. So we've added a feature for this on the endpoint as well. Now there is a new section on the configuration file called OTLP, where you can just list the attributes you want in your metrics. This is safe to enable. By default, it won't be promoting anything, so you won't have crazy cardinality or like UI, UX issues. And what we recommend is that you just, from the recommended list that we gave you before, you see what you need, and then you go through to this list and add them. Yeah. So you curate it for your own use cases. Right. Delta temporality. So for those of you unfamiliar with this concept, I think it always makes sense to explain this a little bit. I've been working with this for like the last year, and I have it internalized, but some people is unaware. So in monitoring, and according to the OTel spec, there are two accepted temporalities. One is the cumulative one, and the other is the delta one. And I always picture it the same way in my head. Imagine a counter that every 15 seconds increases by 5. In the cumulative world, you would see the accumulated value. So 5, then 10, then 15, then 20. And that's what we get in Prometheus. This is because in the pool-based approach, you're always exposing metrics, and so you see the accumulated value. And Prometheus is kind of expecting a point on a fixed interval for then the functions like rate and increase to work. But in the delta world, you don't see this. What you see is the difference since the last observation. So the same counter, instead of producing those points, will be just producing 5, 5, 5, and 5. And then you will have to have a completely different function going through the data. So what we've learned in the last year is that if you're coming from a cumulative system, you don't need to do anything. It probably will just work out for you. But if you're coming from a delta monitoring system, such as StatsD, Graphite, or a particular vendor, then we actually recommend that you use the delta to cumulative processor in your collector. This processor will take the samples, aggregate them, and then produce the accumulated value on a fixed interval. So it's actually doing the work for you. And if you're using the OTel SDK, you don't need the delta to cumulative processor. You can actually switch the temporality. So both temporalities are implemented, and you can do it. But sometimes you cannot do it because maybe you want to keep the previous delta system with Prometheus. So yeah, in your pipeline, you can just say the traffic that is going to Prometheus, put the delta to cumulative processor in the middle. And yeah, we've also thought about adding delta temporality support in Prometheus, but it's a bit challenging. In theory, we can already ingest the samples, because anything that you ingest, the TSDB will take it. But the main issue is found at the query engine, because it's kind of built with cumulative temporality in mind. And it's not a problem, it's the way Prometheus was and always been. But in order to support like going through the samples, we will have to either refactor the engine or add new delta functions to do rate calculations. And a few more words on the delta to cumulative processor. I think it has a year or something like that, but it's very active. The community has done around 40 PRs so far this year, and it's slowly getting more maturity. So the OTel spec defines 4 degrees of maturity. You have development, alpha, beta, and stable. So I think it just reached alpha, which is, yep, it's getting there. And yeah, we know we touched a lot of different topics, and many of them are canons of worms. So it's hard to retain, and each of them require context, and easy to forget as well. So we've decided to publish a guide with all these recommendations, so that if you find yourself configuring a collector to write into a Prometheus server, we hope this helps. And we are also committed into trying to keep this up to date. Right now, it's a very simple guide. We kind of just wanted to have something to work on and as our reference point. But yeah, we're committed to keeping it up to date with all the new things that come out in the following months. And yeah, we hope it's useful for you. And that's it. Thank you very much.
I'm sure you all have questions, so who has questions? There we have one.
Okay. Well, thanks for the talk first. You talked about storing metadata in Prometheus as well, and so many plans to add it to Prometheus. Will this include also metadata about the metric type and in the SDK you can also set like a unit for the metric and this kind of thing? This is something in our team that we are interested in. So will Prometheus also store this kind of data?
That should be standard Prometheus metadata about metrics. That is one of the planned use cases that we want to, when we have the metadata store, we want to persist those metric metadata correct.
Hey, Arve. I'm excited about the info. Sam over here. Hey.
Yeah.
So you said it joins on job, I think, an instance?
Yes, correct. So it's a bit dumb at the moment because it doesn't have any intelligence about the individual infometrics. So it just assumes job and instance because those are the conventional identifying labels of the target info metric and probably some other infometrics.
So what about like, that's great for OTLP. We encounter metrics. We use infometrics and join them on things like org ID label or probe label. Is it possible to configure the label you're joining on when you call the info function?
Not currently. Like the version of info that we are proposing for merging into Prometheus is explicitly an MVP. And for that, we've decided to support only infometrics that have job and instance as their identifying labels. So by default, it will assume the target infometric, but you can also, via the name label matcher, specify other infometrics. But again, they have to use job and instance. So then I guess it's like then the question would be like after the MVP, should we make it configurable? And then I think it's like a question whether Prometheus developers would accept, basically changing query behavior through configuration, if you see what I mean. So I'm not sure if that will be. I'm not sure if that will be supported.
Thanks. I have a question here. Yeah. So you showed the info function, to join on the labels, and you explicitly, the example, you explicitly have the name of the label you want to add with a filter on it. Can you put a glob on the name saying I want every label starting with K8S to be joined, or is it something that needs to be added?
No, that I don't think that we have any support for that. You can instead via the _name, _label, say which infometrics you want to join with. But otherwise, if you don't provide any label matcher, info will pick all labels it finds.
So if I want every label from K8S, I will have to explicitly name them, all of them in the.
Yeah, I don't see any option otherwise.
Okay, thank you.
Yeah, I think that picture is showing what you said. And we explicitly wanted to, if you want any label, you have to add it to the matcher. It's because at scale, if you think about it, you want this behavior because otherwise you're bringing in too much data. You could have 100 labels with different values. And it's like if you want something matched for it, it's like an SQL query where you match for the rows, the columns you want. Yeah.
More questions?
Hello. One question is about the delta to cumulative problem that we have. Have we considered in Prometheus doing the same thing that the delta to cumulative processor is doing? Like we receive deltas, we aggregate for an interval, and then we ingest only the result.
Right. Yeah. So it's been thought of. but there's a lot of things to do. So basically what we've said is this delta to cumulative processor is being used widely. Let's see how it goes. Let's see what issues they face. Learn from that, and then reevaluate after some time. Do we want to provide a native solution for that in Prometheus? Because we could we could be doing the same thing in Prometheus as well. But yeah, we're just giving the processor time to be there and do its thing, and then maybe evaluate whether it's needed or the processor is fine. Yeah.
Any other questions?
Hi.
Hi.
I was just wondering, you showed some numbers that it's like 40% faster, 60% less memory. I was wondering what to expect. Like, do you have any absolute numbers on what the translation times are?
So these numbers are from benchmarks, Prometheus benchmarks. I don't think we have measured the average latency.
Yeah. I think they are compared to the initial version we had, right? And the improvements have been mostly around reusing the same structs when doing the translation and the series as well. Yeah. But it's based on the first commit to the state that we have now at the moment. We could probably pull the benchmarks, right? They are on the PRs, I think.
Sorry?
The benchmark results, I think they are on the PRs.
Yes, I think, yeah, I have. So the benchmark results I posted here I've run recently, so they're not reflected in the PRs. So basically, what I did was I compared to the translation code before my optimizations and then the current state, if you see what I mean. So that's basically the measurements we have.
Okay, thanks.
Any others?
Nope. Awesome. Then thank you again, Jesus and Arve. Big round of applause.
Thank you.